All right, so for section 1-2, here are some of the questions that people had over some problems. Starting with 51 here, where you had to write this without a radical symbol. So it says a square root of x squared plus y squared. Remember, when this is here, then that turns whatever. Anytime you have something like this, like that turns it into something to the 1/2 power. So because this is everything underneath, it would become x squared plus y squared in parentheses to the 1/2 power. Now, guessing that you're thinking, hey, this is a 1/2 power and then this is x squared plus y squared, so I can give this, distribute that to the two things inside, but you can't do that because of this addition sign. This is considered one thing then. If it were x squared y squared to the 1/2, well, yes, now you can do that to both of those two things, turn it into xy. But once that plus sign comes into play, then you cannot distribute that to those two things. If you look at this, okay, let's say, for example, you had the square root of 2 squared plus 3 squared. 2 is x, 3 is y. Well, 2 squared is 4, plus 3 squared is 9, and the square root of 4 plus 9 is the square root of 13. Well, if you do something like this, where you give those two things, give the 1/2 power, if you write this with a 1/2 power, it would be 2 squared plus 3 squared to the 1/2, and then if you give that to both of those and distribute it, you would get 2 plus 3, which is 5. And 5 is not the same as the square root of 13, because the square root of 13 is roughly 3 point something. So then this right here is what your final answer should be. All right, moving on to this, you were supposed to write using a radical symbol. Well, since this is 4x to the 3/2 power, nothing is happening with the 4 because that is not part of the 3/2 power. It's only the x that's raised to the 3/2 power. And so then this turns into the square root of x to the 3rd. Here now we have both of these, it's in parentheses to the 3/2 power. So therefore the square root would be like this, and it would be 4x to the 3rd, which then you can turn that into 4 to the 3rd x to the 3rd square root, and 4 to the 3rd is 64, and the square root of 64 is 8, and then we'd have the square root of x to the 3rd. And I suppose because that's a square root and x to the 3rd, you can divide, because this is a 2 here, and 2 divides into 3 one time with a remainder of 1. You could turn this into 8x square root of x. Because 2 goes into 3 one time, that's why you have x the first on the outside, and then there's 1x left over. All right, moving on. Whoops. 259 was the 5th root of a negative 64. Well, let's see. Since it's a odd root and negative, there should be something that you can get to that. If you break that down to 8 and 8, well, that would be 2 times 2 times 2, and that 8 would be 2 times 2 times 2. I'm not sure what's happening here. Those are supposed to be 2s. upside down for some reason. So this is, and because, okay, so there has to be a negative sign here, and we're doing fifth root of that. Well, how many 2's are there here? 1, 2, 3, 4, 5, 6. Well, you can take 5 of them because this is fifth root, and they can depart as a 2, actually as a negative 2. And then you still have 1, 2 left underneath. It would be a negative 2 times the fifth root of 2. Because no matter what this number is here, you need that many of the same number in order for them to depart the scene or depart the radical symbol as one thing. Alright, here we have 1 over the cube root of 2. Well, we would need 3 of these in order for us to be able to do something with it. So we're going to have to multiply by some form of 1. And the cube root of 2, and how many more 2's do we need? Well, we need 2 of them. So the form of 1 is going to be the cube root of 2 times 2. Now the denominators, when you multiply all those together, well, there's 1, 2, 3 2's, and it's a cube root, so that's just going to be a plain 2. And then the numerator, 1 times this, is going to be the cube root of, and 2 times 2 is 4. If this would have been like, let's say, 1 over the cube root, not the cube root, the eighth root of 2, well, you do the same thing. Eighth root of, we need 7 more 2's. Do that on the top too. Eighth root of 5, 6, 7, which would make the denominator just 2. And then here we'd have eighth root of, and 2, 4, 8, 16, 32, 128, or 2 to the 7th power. Right, here we have the square root of, for 67, 3x over 2y to the third. Oh, hey, right away, because this is square root, there has to be a 2 here. And this one has an exponent bigger than that. So that can factor to y times y times y, which a pair of them can leave. And they're in the denominator, so you would have 1 over y, and then you'd still have the square root of 3x over 2y. And now you cannot have any square root fraction underneath, so it turns into square root of that and square root of the numerator. So you have 1 over y times the square root of 3x over the square root of 2y, which means we then need to multiply by the square root of, we need a 2, and we need another y. So 2y times 2y would be 4y squared, but the square root of that then would turn into 2y. Well, we already have a y out there, so it becomes 2y squared. And then this numerator, square root of 3x times the square root of 2y would be the square root of 6x y. All right, for 69, this one, it's 2x to the fourth, y to the fourth over 9x. Now, first you see there's an x here and there's an x here. So we can divide an x out, so that x goes away and that turns into x to the third. So now we have cube root of 2x to the third, y to the fourth over 9. A couple ways you can go, but this, since this is 9, that's the same as 3 times 3. So we need how many more 3's to get rid of the cube root of this thing in the denominator? Well, we need one more cube 3. So we have to multiply the numerator and denominator by the cube root of 3. This 3, that 3, and that 3, that would be 3 to the third power, but we have cube root of it. And the cube root of 3 to the third is just plain old 3. The numerator then, 2 times 3 is 6, x to the third, y to the fourth, and it's still cube root. Now there's no cube root for 6. If you try to factor 6, it's just 2 times 3, and you can't break anything down. You can't divide that 3 and this 3, because this 3, if you break this to 2 and 3, that's still underneath the cube root, and this one's not, so you can't divide those out. Then looking at the x's, hey, this is a 3 and that's a 3, and 3 divided by 3 is 1, so there's going to be an x on the outside of the radical symbol. And this is a y to the fourth, and that's a 3, so that's y. Let's see, the y's, there's 4 inside, and there's a cube root, so 3 goes into 4 one time, so a y is on the outside. And there's a remainder of 1, so there's a y to on the inside yet. And that 6 is still there. And then the 3 is in the denominator. Now you might see this answer written as x, y divided by 3 times the cube root of 6y. Same thing, just a different way to write it. So remember, anytime you have a root here, when you have variables with an exponent, just take that root, divide it into that, and how many times does it go in? One time, and there's no remainder, so that's why there's no x underneath. But with the y's, 3 goes into 4 one time, so, and then there's 1 left over. Had this been to the 5th power, then you would have y squared here. And let's say this would have been x to the 8th. Well, now 3 goes into 8, x 2 times, because 3 times 2 is 6, that which leaves 2 x's left. So then you also have an x squared there. All right, next one is the 4th root of 5, x to the 8th, y to the 3rd of 27x squared. Okay, again, right away, because you have an x squared and an x to the 8th, you can divide the x squared out. Turns that into x to the 6th. 27, hey, that's 3 times 3 times 3. But we need 4th root, so we have to multiply by the 4th root of another 3 in both the numerator and denominator, because that's just 1. Now, 3 times 3 times 3 times 3 is 3 to the 4th, and the 4th root of that is just 3. In the numerator, we have a 5 times a 3, which is a 15, x to the 6th, y to the 3rd, and it's still 4th root. And then there is no 4th root of 15, and you cannot divide the 15 and the 3 because the 15 is underneath the root, the 3 is not. So we'll just leave those two things. So we're going to put over here the 4th root of 15, and a 3, and now this is x to the 6th, and it's 4th root, so 4 divides into 6 one time, so it's x to the 1st power, or just x. And when you divide 4 into 6 one time, there's 2 left over, so that means an x squared. Now with the y's, 4 does not divide into 3. Well, it does 0 times, so there is no y on the outside. And there's a remainder of 3, so y to the 3rd. So here is your final answer. which, like the last problem, they could write the answer as x. So 3, and then the fourth root of 15 x squared y cubed. Either way that you write it would be fine. All right, for 73, it's the fifth root of 5x to the seventh y squared divided by 8x to the third. Well, hey, look at that. Got an x to the third and divide out, and an x to the third, which turns that into x to the fourth. And 8 is the same as 2 times 2 times 2. Now, that's 3 2's. We have fifth root. So therefore, we are going to have to multiply by the fifth root of 2 more 2's, because we need 5 2's total. And 2 more 2's on the top. So therefore, let's see. 2 times 2 times 2 times 2 times 2 is 2 to the fifth, and the fifth root of 2 to the fifth is 2. And in the numerator, we have a 5 and a 2 and a 2, which is 20. And it's still fifth root of that. And x to the fourth, y squared. And that's all you can do with that one. Yes, 20 divides down to 5 times 2 times 2, but there's not, since it is fifth root, there's not 5 of something that you can get rid of it and move it to the outside. And you can't divide the 20 and the 2 because the 20 is underneath the root, the 2 is not. 75, it's the fourth root of 3x to the fifth y to the negative 2 to the fourth power. Well, hey, would you look at that? Here we have a fourth root and a fourth power. And when you have a fourth root and a fourth power, just like when you have a fifth root and a fifth power, and a fourth root and a fourth power, and a third root and a third power, you just get that answer. So, with this, because this is here and that is there, those two things, they're kind of inverses of each other. So they go away and you're left with 3x to the fifth, y to the negative 2. And then when you have a negative exponent, you can turn it into this. And then you're done. 477, oh, yuck. We're multiplying. Fifth root of this times the fifth root of that. Well, guess what? We're still going to have a fifth root. 8 times 4 is 32. X to the third times x to the fourth is x to the seventh. Y to the fourth times y to the second is y to the sixth. And now we have the fifth roots. Can we simplify this? Well, there's a couple ways to go about this. One way, you could multiply right now by the fifth root of y to the sixth on both the numerator and denominator. Then you're going to have more simplifying to do if you do it right now. Because this is a fifth root, and this is a 6 here, and that's a 7, and 32, hey, 32 is 2 times 2 times 2 times 2 times 2, isn't it? 2, 4, 8, 16, 32. It is. Hey, and how many 2's are there? There's 5 of them, and it's fifth root, so it's going to be 2. And now how many times does 5 go into 7? That's right, it's 1 time, so x, and the fifth root of x to the second over, and 5 goes into 6 1 time, so there's a y down here, and then the fifth root of, there's 1 y left over. And then can't leave a root in the denominator, so we have to multiply the numerator and denominator by the fifth root of, and there's one y, and it's fifth root, so we need 4 more. So denominator-wise, hey, you've got a y, and you got y to the fourth, which is y to the fifth, and the fifth root of y to the fifth is y, which there's already a y, so y times y is y squared. And then we have 2x, and the fifth root of x squared y to the fourth. And then here's our final answer. Now if you do it this way by multiplying the fifth root of the y to the sixth and for the y to the sixth, well, that is going to be y to the 12th, which would not be good. You'd want to go y to the 4th. Sorry. Why y to the 4th? Well, because there's already 6 here, and let's see, 5 goes into 5, 10, 15, and 20, so if you have 4 more y's, y to the 4th and y to the 6th turns into y to the 10th, and the fifth root of y to the 10th is y squared. And then if you simplify this and this, you would get this right here. So that's why I think it's easier to simplify this first and then figure out what you have to multiply by second. Hope that was a good explanation. If not, you can ask me about it again on Thursday. All right, here's our last one. Same thing, we're multiplying cube root. And since they're both cube root, 3 times 9 is a negative 27. T to the 4th and t to the negative 1 would make t to the 3rd. V to the 2nd and v to the 4th makes v to the 6th. That's not a 6. 6. There you go. All right. Now 27 is 3 times 3 times 3. And it's cube root, so cube root of 3, 3, it would be 3, and since it's negative, it would be a negative 3. T to the 3rd divided by 3, 3 divided by 3 is 1, so there'd be a t. V to the 6th, 6 divided by 3 is 2, so v squared. And there's your final answer. And that would be all of the ones that you asked about.